Hello, hi Niranjan. Good evening. Am I audible?
Good evening, sir. Yes, sir. Audio.
Hi, how are you?
Fine, sir.
Great. So I hope you were able to solve the assignment 7
Yes,
and
sir.
nice to know. And this week we will study Schmitt trigger because this week's assignment is based on the topic Schmitt trigger and how to measure the frequency of any unknown signal using meters. Right? So there are certain types of meters which is generally used, or you could say like with the help of direct or indirect frequency measurement instruments. Okay, so let us solve some circuits based on Smith trigger, and I hope you are aware with the term hysteresis band. Because there will be certain band or certain range of the value for which, because there will be a comparator. Let us assume one has some input 1 and other has some input 2. Okay, and we have one output, and this op amp has limit of plus vsat and minus vsat. So the general trend which comparator follows, if input 1 is higher than input 2, which means this V in terminal, this V plus and this V minus. If V plus is higher than V minus, then output is going to be what? Plus V sat.
Positive flow.
Exactly. And if V plus is less than V minus, then V out will be equal to minus V sat. This is the simple rule which we will follow in all the problems based on Schmitt trigger, and we will be able to solve all the problems. Okay.
Okay.
So now let us start with the first problem. One op amp is there with plus minus 12 volt of saturation limit. Okay, and here positive terminal, or you could say non-inverting terminal. One resistance is connected to ground with 6 kilo ohm. Okay, and here 1 kilo ohm resistance is connected to a supply, which value I will just provide. Okay, and here from output, again a 6 kilo ohm is connected from the inverting terminal. Okay, and here we have 1 kilo ohm of resistor, and there is some voltage between these two terminals which is known as V in. Okay, now this is our circuit. In last lecture we conveniently applied virtual ground concept. We used to calculate one terminal voltage or one point of contact voltage, and we used to know that V plus is equal to V minus. Okay, excuse me, there is some mistake here. They are opposite actually, minus plus. Okay, so can we do that the same thing here?
No,
Can
sir.
we do? No, exactly. Yeah. Why? Could you please tell me the reason?
यहाँ पे पॉजिटिव फीडबैक है इसलिए सर.
अच्छा यहाँ पे yes 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 right, यहाँ पे positive feedback है. And another thing is, both the terminals are connected to some different supply or some other supply, right? So potential at both the terminals will not be same because their circuits are different and all of them are biased with different voltage level, right? Did that make sense, Niranjan?
Yes, sir.
So we need to calculate hysteresis band. how to calculate. Hysteresis band will have certain, you know, upper limit, UTP, and LTP. So we have to find out this gap. For that, what we could do, we have to find two conditions, two threshold values we have to calculate. Beyond that, this output should, switch from plus 12 volt or minus 12, plus 12 volt to minus 12 volt. So this V naught could be either plus 12 or minus 12. It couldn't stay in between. Okay, it has to be either plus VSAT or minus VSAT. So in that case, we have to, find out the relationship between, this V minus or V plus, inverting terminal voltage and non-inverting terminal voltage. And we have to, get the value in their difference, and we have to equate whether they are greater than 0 or less than 0. Okay, so can we do that?
Yes, sir.
Okay, so let's do that.
Yes, sir.
So first we could calculate V positive, which will be equal to how much? V naught into 1 kilo ohm plus V in into 6 kilo ohm divided by
By 7 kilo.
7 kilo.
7 kilo.
Okay, just with the trick which we discussed in the last lecture. Okay,
Yes, sir.
yeah. Now we have to find out this V naught. V naught and V in. There are two, independent variables, that is unknown value, and we have to find at least one to get the relationship between V in and V naught, right? So let us also calculate V negative. How much will be V negative? How much will be it?
V in minus V in
V in
into
minus
6.
V in minus how much?
Minus no. V in into 6 kilo ohm
V in into 6 kilo ohm
by 7 kilo.
by 7 kilo ohm. Okay, so
Yes,
this
sir.
much you are saying, that should be, I think, fine.
यहाँ पे माइनस होगा ना सर, नीचे वाला में V प्लस जो निकाले हम लोग.
अच्छा ये वाला, राइट?
यस सर, यस सर.
वो वैल्यू लिखते टाइम हो जाएगा, या यहाँ भी लिख सकते हैं.
ओके सर, ओके सर.
है ना? Okay, so and we could, calculate the difference between both of them. V plus minus V minus would be how much? V naught by 7 minus V in minus 6 V in by 7 minus 6 V in by 7. Is it correct?
यस सर.
Okay. So now what we have, the all the values, V naught by 7 minus 12 V in by 7. And to calculate the LTP, like when LTP will be reflected in this output of the circuit, when, V naught value or V in value, which one? V naught should be, if V naught is equal to plus 12 volt, okay, and then UTP will be V naught is equal to plus 12 volt when V positive is greater than V negative. Okay, right?
Yes,
It
sir.
means this V positive minus V negative has to be greater than 0. And in that condition, we at the place of V naught, we could write plus 12 volt, isn't it? This will be higher than 0 if at the place of V naught, we could replace it with plus 12 volt. Is that point clear?
Repeat again, sir.
Huh. So see, V V plus if let me just rephrase it. If V plus is higher than V minus, then output is equal to plus V set, right?
Yes, sir.
And plus V set is plus 12 volt.
Yes, sir.
And at this
Right.
condition, V plus minus V minus is higher than 0, right? So that is what I am
Yes,
doing
sir.
here. Yeah. So that is why we have to plug in the value of V naught as plus 12 volt.
Okay, sir.
Okay.
Okay, sir.
Now, if we calculate 12 by 7 minus 12 V in by 7 greater than 0, then it will be V in will be equal to 0. V in should be less than 0, right? Here we are getting value as V in should be less than 0. But I think we committed
One
some
होगा ना
mistake.
सर? One आएगा ना
Okay,
सर?
yeah, one. Sorry, sir.
Yes, sir.
One, yeah, thanks. So V in should be less than 1. Okay.
Greater than
And
one होगा ना सर?
if you further simplify it, 12 by 7 is higher than 12 V in by 7, right? So V in is
Okay, okay, okay. Okay, right, sir.
1, V in is less than. Okay.
Okay, sir.
And for other condition is what? If V plus minus V minus is less than 0, then V naught is equal to how
Minus
much?
minus V supply.
Minus V
Minus V
supply.
supply.
That is minus 12.
That is 12 volt.
Okay. And V minus, have you calculated V minus correct? I'm having some doubt here. Let us do one thing. Yeah, there is some mistake in V minus because mm, in calculation of V minus, all these factors, all this current, all this current will come in the picture. Okay, these all current will flow like this, all other way around. So there will be current which will be affecting both the paths. So hence it is not separated as virtual grounded op amp. It is different circuit. So we have to particularly take care of both the values. So now if you calculate I will be how much? This current, I will be how much? V naught minus V in, that is plus V in, divided by 7 and 7, 14 kilo ohm, right? And now, if we calculate V in, we have to do 6 into V minus or 6 kilo ohm into this I. So V minus will be, and we will we will equate with the earlier value. If both will be same, then we can assume that we did correct thing. But I am having doubt here because the second path we did not consider in that calculation. So that is why here the impact of V naught will also be there. So in this expression, you could see there is V naught absent, but impact of V naught will be on the inverting terminal as well as non-inverting terminal. So let me see. So V minus will be equal to 6 kilo ohm to V naught plus V in divided by 14. So it will be V naught plus V in by 2. Okay. So this much is the value of V negative. So we will have to update it. So V plus minus V minus. So V naught
ये
by, yeah,
6/14 सर यहाँ पे मिस्टेक है क्या सर?
यहाँ पे 6/14, this one.
यस
So
सर भाई वो तो
see how much will be V minus? V minus will be how much the current is flowing in this branch, right? From this node to ground. So that is why what I am doing here is nothing but V minus is equal to 6 into I, and I value is this much. Again, should I simplify it? See, do you agree that in this circuit V minus is equal to 6 kilo ohm into I? Do you agree?
यस सर
Okay. And I we have already calculated that V naught minus minus V naught minus V in divided by total resistance 6 kilo ohm plus 1 kilo ohm plus 1 kilo ohm plus 6 kilo ohm. Right? All the resistances will be there. So total
ओके
14 kilo ohm. Right? So what I am doing is V minus is equal to 6 kilo ohm into V naught plus V in divided by 14 kilo ohm. Right?
राइट सर
Okay. So this much is the V minus, right? So we have to equate with it. First, let me write this equation in simplified version. So minus 6 V in by 7. And further we will plug in V naught by 7 minus 6 V in. We have V naught plus V in by 2. Okay. So we have here V naught by 7 minus 6 V naught by 7. So total minus 5 V naught by
ये
7.
टर्म सर आपका V प्लस V नॉट प्लस V इन बाई 2 ये थोड़ा मिस्टेक है क्या सर? ये
क्या है
जैसे
ये
3 बाई
क्या है?
6 किलो ओम बाई 14 किलो ओम ये कट के
Hmm.
तो आपका 3/7 आएगा ना सर?
Oh, sorry. Yeah. Sorry, that step is wrong. Yes, 6 by
यस
14. Okay, sorry. Thanks a lot. 3, 7. So 3 by 7.
राइट सर
3 by 7. So minus 6 V in by 7, and V in is 3 by 7. Into 3 by 7. Right? 3 by 7, V not percent. Yeah. So mm, V naught by 7 minus 18 by 49 V naught minus 18 V in by 14. Okay, I think now it is fine, right?
ओके सर राइट सर
Right. Maybe minus Vn is equal to minus Vn plus. Now what we could do, we could simplify it. Minus 7, 7 minus 18, 11. Minus 11 V naught by 49 minus 18 V in by 49. Okay, this is the difference between V plus and V minus. Okay.
Okay, sir.
Now, if it is equal to 0, then V naught is equal to plus 12 volt, right? Then V naught has to be plus 12 volt. So minus 12 into 11 by 49 minus 18 V in by 49 has to be equal to 0. If we further equate it, 18 V in 18 V in plus 12 into 11 should be less than 0, right? Because we are taking it on the right hand side. So we are eliminating this sign and it will convert to this. Now
Yes, sir.
V in should be less than minus 12 into 11 by 18. 2, 3, which will be equal to minus 22 by 3. So if V in is minus less than minus 22 by 3, then we have output as plus 12 volt. Okay. Now we have to
Yes, sir.
find out another condition. So far so good, right? Any difficulty in this?
No, sir.
Okay. So now we have to calculate the negative side also, right? Hmm. So we have to calculate that when V naught is equal to minus 12 volt. So in that scenario, V plus minus V minus has to be less than 0. Okay. And we have calculated V plus minus V minus, which were 12 into 11, or this 18 V in minus. Okay. So we have to use this equation again. This was the expression of V plus minus V minus, right?
Yes, sir.
So V plus minus V minus is equal to minus 11 V naught by 49 minus 18 V in by 49. Okay, this has to be less than 0. Now at the place of V naught, what should I plug in? Plus 12 or minus 12 if we have this condition?
Minus 12. Minus
Minus
12.
12, exactly. So I have to plug in here minus 12 volt. So minus 12 into minus 11 divided by 49 minus 18 V in by 49 should be less than 0. So we have now 12 into 11, which is equal to 132, I guess.
Yes, sir.
132 minus 18 V in is less than 0. So if we take 18 V in on the right hand side, so V in should be higher than 132 by 18. So which is equal to 132 by 18. 22 by 3. And yeah, so minus 22 by 3 to plus 22 by 3. So we have LTP is equal to minus 22 by 3. That is the lowest possible value of the input voltage. And other is UTP, which is plus 22 by 3. So the hysteresis band will look like something this. Okay, here plus 22 by 3 and minus 22 by 3. Okay, and what will be the total? The question was asked to calculate hysteresis band value. So how much will be the hysteresis band? Hysteresis band will be UTP minus LTP. That is
Right, sir.
20, 22 by 3 into 2. So 44 by 3. So 44 by 3 will be the answer to this question. Is it fine?
Yes, sir.
Okay. Right. So I hope you understood the concept of Schmitt trigger, right? All basically it is an indirect uh, question of comparator. So in comparator, it depends on the input value. So if we have comparator, so it compares the value between positive terminal and negative terminal, and whichever is the higher or larger, that will be the outcome of the voltage, which will be the saturation value. So this is how we solve the problem based on Schmitt trigger. Okay, so we will see some more problem like this. So I think we will get acquainted with the concept, I guess. So let us consider one more circuit like we saw in last lecture. But yeah, it is like it is very common that it is a positive feedback circuit. Schmitt trigger is positive feedback circuit that you rightly pointed it out. Here V naught is there. Yeah. But two things you will always observe that both the terminals are connected to different kind of supply. Or there is two kind of bias on both the terminals, inverting or non-inverting. Okay. So it is 5 volt, 2 kilo ohm, and 8 kilo ohm. And again, its limit is plus minus 12 volt. Okay, so this is a Schmitt trigger circuit. I think you will be able to recognize. Now we have to find out UTP. Okay, so how much will be UTP and what is the way forward? So the first thing we should do, we should annotate with V minus V plus. The first thing we could do. Okay. Now both the voltages cannot be same, right? And virtual sorting principle will not be applicable here. So first thing we could do, we should calculate V positive because V negative we cannot calculate. Now that is V input, and that value we can V input we have to find out, right? The limit of V input or how much the value of V input should be there or higher than that or threshold value of V input so that our output changes from plus V naught to minus V naught, right? Or minus V naught to plus V naught. So for that, first we could calculate is V positive, which is this much, okay? And what will be V positive? We have solved this kind of circuit earlier. How much will be the V positive?
V naught into 2 kilo ohm
V
plus
plus
8 kilo ohm into 5 volt by
into
10
5
kilo ohm.
volt by 10 kilo. Excellent. So we are very close to calculating V positive, which is 2 V naught by 10 or V naught by 5 plus 4, 4, we could say 4, right? Yeah, yeah, it is 4.
Right, sir.
this V positive. Now, V negative is V in. Now we have to compare V positive minus V negative. How much it will be? V naught by 5 plus 4 minus V in. Okay. Now if we solve, V naught by 5 minus V in should be higher than, or let, yeah, if it is higher than minus 5, in that case, what is happening is, since V naught is higher than V negative, in that case, we have to plug in V naught as which value? Plus 12 or minus 12? Which value? Mhm. Which value will be it? Niranjan
Yes, sir.
or anybody? Which value will it be? Because in our question, we have to calculate UTP first, right? So which value will it be? How will we calculate UTP? Simply, in last question also we
Minus
solved.
12.
Yeah, Sangeeta, go ahead. Oh, minus 12 volt. Yeah, NS has answered minus 12 volt. So, yeah, minus 12 volt should not be the answer. Why? Because mm, if V plus, simple, this circuit is very simple, right? See this comparator. If V plus is higher than V minus, then what will be the output? V naught will be equal to plus 12, right?
Positive, sir.
Very simple.
Yes, sir.
You have to just observe the circuit. If V plus is less than V negative, then V naught is equal to minus 12 volt.
Right,
So
sir.
if we are equating V positive minus V negative is higher than 0, that is what I did here, right? Then what will be the value of output?
Positive, sir. V
Positive,
positive.
plus 12, exactly.
Yes, sir.
So plus 12 by 5 minus V in is less than minus 4. Okay. Now
Okay.
here V in will be less than 4 plus 12 by 5. I hope it is fine till now. You are following. So
Right,
V
sir.
in should be less than 4 plus 12 by 5, which will be 12 by 5, how much? 2.4. So 4 plus 2.4, 6.4. So V in has to be less than 6.4. So we have calculated UTP of this hysteresis band. Okay. So this is 6.4. Okay, right now I am drawing it as symmetric, but it could be asymmetric along the x-axis, along this axis, right? So let us see what will be the negative value or LTP of this circuit so that we will be able to identify. So the upper limit is 6.4. The lower limit has to be how much? So again, we have to do the same thing. V plus minus V minus has to be less than 0. Okay. And for this condition, V naught will be how much? Plus 12 or minus 12?
Minus, sir.
Minus 12. Okay. Now we have the expression of V plus minus V minus. I will just copy it, and or if you are solving on pen and paper, you just take this as a reference. Now this is the expression of V plus minus V minus, right? So what I can do, since I have the provision of cut copy paste. So I will just copy it and I'll paste it here. Okay. So this is our expression of v plus minus v minus, and this time it has to be less than 0. Now v naught by 5 minus v in, and here at place of v naught you have only told that v naught is equal to minus 12 volt. So now this time I'll plug in the value minus 12 volt. So let me also write that minus 12 by 5 plus 4 minus v in has to be less than 0. Now if I'll take v in on the right hand side, so v in is equal to, oh sorry, greater than minus 12 by 5 plus 4. So again, minus 12.5 is 2.4. So it is higher than minus 2.4 plus 4, which will be equal to, or V in is greater than how much? 4 minus 2.4, 1.6. So V in has to be greater than 1.6 volt to provide negative output or negative saturation value, which will be V naught is equal to minus 12 volt. That's what we plugged in the expression. So now our Schmitt trigger hysteresis band will look like something this. This band will shift upward, right? The lower LTP will be equal to 1.6 volt. This one was UTP. So it will shift upward. So this, let us assume 0 axis, right? So it will be like this. So this is 6.4, this is 1.6, right? So this is how our hysteresis band will look like. Is it fine? Any doubt in this problem with respect to this problem or any Schmitt trigger circuit? Any doubt? NS, Sangeeta, Niranjan? Okay, great. NS is saying no. Okay, Niranjan is also no. Okay, great. Let us move on to the next part. One more problem. So again, how much will be the value of hysteresis band for this question?
6.4 minus 1.6 is
6.
equal to
Excellent. Yeah, is equal to 6.4 minus 1.6.
4.8.
4.8. Nice. So that much is the hysteresis band in which our output will keep switching from plus 12 to minus 12. Okay. Okay. So we will see one more problem, and I hope after that you will be having crystal clear about this topic. So let me draw one more Schmitt trigger circuit, which is something like this. Okay. And since it will have positive feedback, so the feedback is connected to positive terminal, something like this, V naught, and negative terminal is having one supply voltage of 2 volt, and positive terminal has supply V in. This V in will have to be decided based on hysteresis band. Okay, and this 32 kilo ohm is the feedback resistance, and again we have the saturation limit is 12 volt. Okay, so simple. Again, the first step is to take both the limits, or first identify the node. This is V plus, this is V minus. Okay. So do not get confused that V minus should always be negative. It could be positive. It's just that we need to know the difference between these two terminals. Okay. So V minus is here, as you could see that V minus is equal to how much? 2 volt.
2 volt.
And V plus we have to calculate. Again, how to calculate with the shortcut? How much will be the
V in
value of V
into
plus?
32.
V in
V in
into
into 32.
32 plus
kilo ohm.
hmm,
V0 into 4 kilo ohm
V0 into 4 kilo ohm divided by
by 36 kilo ohm.
36 kilo ohm. I hope it is fine with everybody. We are just doing the voltage division rule with two terminals, or KCL you could say. If you apply KCL also, you will get the same value of V plus. Okay. So you have to take one terminal voltage and multiply with the resistance of the other terminal and take this and take this and divide it by addition of all the resistances, right? So that is what we have been doing. So we could simplify it 32 by 36, so 8 by 9 V in plus V naught by 9. So this is the value of V plus. Now again, we have to, calculate V plus minus V minus. First, we have to calculate V plus minus V minus. Then only we can calculate LTP and UTP, and hence hysteresis band value, right? So V plus minus V minus is equal to 8 by 9 V in plus V naught by 9. And when I am equating them greater than 0, in that scenario, what will be the value of V naught?
plus 12 volt.
Plus 12 volt. Exactly. So 12 by 9 plus 8 by 9 V in is equal to 0. Okay. So here we can say that V in has to be 8 V in should be minus 8 V in, or 8 V in should be greater than minus 12 by 9. Right? We could say that. Then only V naught will be plus 12 volt, right? And
8
V
होगा ना
in
सर, minus 12 by 8 होगा.
minus 12 by okay, yes, exactly. Yeah, thanks. It will be V in will be less than.
तो आप भी
Yeah,
माइनस को ऐड करके खाली तो भी प्लस को ही ऐड किए ना, खाली भी माइनस को 2 वोल्ट देना पड़ेगा ना उसका.
V माइनस को दो वोल्ट देना पड़ेगा. एग्जैक्टली वो दे सकते हैं, बट द थिंग हियर okay, yes, right, correct. We skipped that, so we did not take V minus is 2 volt given. So here we wrote V plus minus V minus, but we left that. Yeah, करना पड़ेगा वो. So we have to equate it with 2, right? Then it should be greater than 0. Yeah, sorry about that. So this step was crucial. Otherwise, we would have got wrong answer. Minus 2
Yes
has
sir.
to be greater than 0. Thanks, Sangeeta. So 8 V in, yeah. So we could erase this step. So now we have 8 by 9 V in is higher than 2 minus 12 by 9. Okay. Now 8 V in by 9 is higher than 18 minus 12, 16 by 9. I hope I am doing correct calculation. So this 9 and 9 will be cancelled out.
No
So
sir,
V in, no?
6 by 9 होगा सर.
Yes. I am very wrong with calculation. Okay, 6 by 9. So V in will be higher
Yes
than
sir, right.
6 by 8. Yeah, thanks, Niranjan. So 6 by 8.
Thank you sir, thank you.
So V in is equal to 3 by 4. So when V in is higher than 3 by 4, we are going to have V naught is equal to plus 12 volt. Okay. So we got the value of UTP, right? This will be the
Yes, sir.
how much? UTP. When V in is higher than 3.4, then V naught is equal to 12 volt. So, mm, okay, so this is LTP actually. If V in is higher than this much, let us suppose they are symmetric with origin for time being only. Okay, so if V in is higher than 3 by 4, if we will get V in is less than some value, that will be UTP. If V in is higher than LTP, and then LTP and UTP are the limits of the hysteresis band. So whatever we calculated, V in is higher than 3 by 4, it is nothing but LTP. Okay, any doubt about this? Why I am calling it LTP? Okay. Now the next step is we have to equate when V positive minus V negative is less than 0. And we have to take care that we have to carefully plug in this value as 2 volt. Okay. So which I missed in last step. Now we could again, I will copy it from here. Okay. Just that we do not have to plug in now plus 12. Instead, we could plug in minus 12 volt. Okay, so now we could say that V plus minus V minus is less than 0, which is equal to 8 by 9 V in minus 12 by 9 minus 2 volt is less than 0. Okay, so here 8 by 9 V in, I have to calculate it very carefully because I have been committing so many mistakes. So I hope it is fine till now. So now we will do 18 plus 12, 30
30.
by 9. Here also 9 I have to take it. Yeah. So this and this. So we got V in value less than 13 by 8, which should be 15 by 4, which is equal to 3.7. So V in is less than 3.7. So the upper value also we got, which is 3.7, 3.75. So now our again hysteresis band will vary from 3 by 4, which is 0.75 to 3.75. So 0, this is actually time axis. So, so this is 3.75, this is 0.75. I hope it is clear with everyone, right? So how much will be the hysteresis band?
3, sir.
3, exactly, 3. So 3 volt of hysteresis band is there. Okay, so I hope you will be able to solve all the problems based on Schmitt trigger. Is that right?
सर इसका यूनिट वोल्ट होगा सर, वोल्ट ही
हिस्टेरिसिस
होगा।
बैंड
यस
का
सर, वोल्ट ही।
क्योंकि ये भी वोल्ट है, ये भी वोल्ट है, तो वोल्ट ही होगा, राइट?
ओके सर, ओके सर।
ओके, और असाइनमेंट प्रॉब्लम भी देख लोगे तो वहां भी लिखा होगा, वहां पे यूनिट्स तो दिया ही रहता है, राइट?
यस सर, यस सर।
Okay, so we are done with the Schmitt trigger circuit. Now uh, we will take some problems based on frequency measurement, which is very critical for this week's assignment. And so you might or might not be having some doubt, but anyway, if questions are there, it should be solved. Okay, so let us move with one problem. And in last lecture, I explained the concept of counter. So I hope you are clear with the counter thing, that how the counter works. If you give one clock pulse, then only that output of one flip-flop will be changing from whatever the previous states, that it will depend. And here, let us start with one problem. A digital frequency meter is used in reciprocal counting mode. So there are two counting modes. One is reciprocal counting mode. Other one is which one? Other one is the
Direct, direct
direct
counting.
direct counting. Exactly, direct counting. So which one is faster?
Reciprocal.
Reciprocal. Excellent. So reciprocal counting mode is faster compared to direct counting. Okay, fastest among these two. Okay, maybe new methods may have come out, but as of now, in books, there are two counting modes are mentioned. Okay, so actually, how they work, that we provide some gate pulse to input, like how we generally measure. So let us suppose we have some rectangular wave. So this is kind of clock pulse. Okay, in last lecture also we saw that we have clock pulse. I am showing it for convenience as symmetric, but they could be asymmetric, because for this clock pulse you could say the duty ratio is 50%, right? Because the positive and zero. So since this is zero, this is one. So both are half half. So we could say D is equal to 0.5. Now, if you are given some gate signal from here to here, okay, this is our gate signal, and we need to find out, and that gate signal is given with negative edge triggered. So let me, how does the negative edge triggers work? You will have one flip-flop, here clock will be connected as negative edge trigger. So in that case, this clock will have falling edges, they will be accounted, and they will be multiplied. So this counter basically how much samples it will count. So it will count 4, right? Because in this period, if you see how many falling edges are there from here to here, not 4,
Three, sir.
it will 3. Yeah, it will be 3.
Three.
So 3 falling. So this counter will count till 3. Okay. And if the frequency of clock is given, or the counter is, so clock frequency, let us suppose we are calling FCLK. Okay. And this is for one complete cycle of unknown signal. Now, if the counter value is 3, okay, so how much will be the frequency of the counter? Frequency of the counter will be how much? If we are getting the counter value as 3, okay, so how much will be the frequency?
Six.
Sorry, 3. You are saying how much, Sangeeta?
That's six.
6, 6. You are saying 6. Okay,
Yes, sir.
good. How? So let us see whether 6, the value 6 is correct or not. With, you know, how to solve it? First, we will have to consider the time period of, but we needed to provide this output 6 hertz. You are saying 6 hertz or 6 FCLK, because we have input as clock frequency, which is unknown. So you are saying this uh, unknown signal frequency should be 6 only, or 6 clock frequency? 6 times clock frequency. So time period of clock, sorry, 6.
6 times clock frequency.
Okay, Sangeeta, thank you. 6 times of clock frequency. So time period of clock we could write as 1 by f clock frequency, or 1 by frequency. Time period is nothing but inverse of the frequency. Okay, now time period of unknown signal is how much? It will be counter value into time period of that. So this will be 3 times FCLK, all 1 by FCLK, because we are dealing in terms of times. So you have to multiply with time, not with frequency, right? So you have to be very mindful about it, that you are multiplying with time period of clock. Okay, which will be nothing but 3 by FCLK. So that will be the time period of unknown signal. So frequency of unknown signal is equal to how much? 1 by time period, which is nothing but FC clock by 3, isn't it? So did you realize, Sangeeta, where did you commit the mistakes? You might have multiplied with FCLK, and I don't know where the value of 2 came in, but this is how it should be. The frequency of unknown signal will be FCLK by 3. Because anyway, the frequency of,
सर और एक बार रिपीट कर दीजिए ना।
हाँ हाँ करता
सर
हूँ,
और एक बार रिपीट कर दीजिए।
ओके ओके करता हूँ. So first thing is that यहाँ पे clock frequency FCLK है, right? तो पहला काम हम लोग करेंगे कि इसका टाइम पीरियड निकालेंगे, which will be 1 by FCLK, right? Now we have unknown signal. One thing we have to keep in mind, that if we are calculating frequency of any unknown signal with the reference of clock frequency, so frequency of that unknown signal has to be lower than the clock frequency, right? Because clock का frequency सबसे ज्यादा रहेगा, तभी तो उससे कम frequency वाला measure कर पाएंगे, right? So that is why इसका टाइम पीरियड भी ज्यादा होगा. सो टाइम पीरियड हम लोग क्लॉक का निकाल लिए, और इसमें काउंटर कितना बार काउंट कर रहा है? 3 टाइम्स. इन वन गेट पल्स the counter is counting the value 3, which means there are 3 steps done in that time period. So that is why we are multiplying here with 3 times of clock frequency. Because अगर ये गेट का जो width है, गेट पल्स का जो width है, that is seeing 3 falling edges, 3 clock edges, right? So we have to multiply with the time period of that clock pulses, not with the frequency. Did you get it, Sangeeta? So that is why we are multiplying it here with 3 times of t clock. Okay. And if time
Yes,
clock is okay, nice, thank you. So if we are equating it with 3 times of t clock, we will have 3 by f clock, and that will be our time period of unknown signal. And finally, if you are going to calculate frequency of the unknown signal, which will be f clock by 3. Okay, so I hope you got this basic concept. We will just solve one problem, and you have to let me know the answer of this. Okay, so this time again, a digital meter, and that is why reciprocal measurement is very fast, because you do not need to go till the entire value of the counter or entire value of the clock period. You just give one pulse. What are we doing? We are giving just one clock pulse, and we are calculating the frequency of our required signal. And in direct mode, what we do, we calculate entire, we go from the first to last, and we see how much cycles are there. So that is how the difference appears, and that is why reciprocal counting mode is considered to be the fastest among them. Okay, so yeah, so let me write digital frequency meter with reciprocal counting mode is counting with counter value. Counter value is showing the value 1461. Okay, this is the counter value. Now the clock frequency is how much? 10 kilohertz. Okay, now we have to know the frequency of unknown signal. So I am giving you a couple of minutes, just go through it and you have to let me know the value.
Sir, 6.84.
6.84. Exactly. This is correct value. So I hope you got the idea how to calculate. 6.84. This is the frequency of unknown signal. So you could see frequency of unknown signal. So you could see that it is so many times less than 10 kilohertz. So it will be always less than F clock. Okay. Has everybody got the same answer? Niranjan, NS? Okay. NS has got it. Niranjan, what about you?
Same, sir.
Same? Okay. Great. So just for the reference, I am going to solve it. So the frequency of clock is 10 kilohertz. So time period of clock is how much? 1 by 10 kilohertz, right? Now, time period of unknown signal, which will be equal to counter value into time period of clock, right? So which is nothing but 1461 divided by 10 into 10 raised to power 3. Okay. And if you take reciprocal of this value, so that will be the frequency of unknown signal. So 10 raised to power 4 divided by 1461. So unknown signal, right? So it will come out to the same value, right? 6.84. I will just verify it once. 10 raised to power 4 divided by 1461. 6.844. Yeah, so this is the value. So I hope you got the idea behind it. Okay. Mm, okay, so we will see one more problem where we have to find out the error, how much error is gonna be there. So you know why error comes, right? Because if you are going to use reciprocal counting mode, and if this gate pulse, where is that gate pulse? If this gate pulse is ending just after the falling edge, let me copy this. Okay. So let us assume that this gate pulse is getting turned off just before and just after one falling edge. So suppose this falling edge is here and our gate pulse is starting just after that, and gate pulse is getting stopped just before that. Okay. So now here this time period or total time is, you know, this much, which is very close to equal. This gate pulse time is equal to time period of four falling edges, or four, you could say, tick clock. Okay, it is very close to that, so I'll have to write in this fashion. But how much it will show, how much actual measurement, if you are going to measure in such a mode or at such scenario, what you will get is equal to time period of how much tick clock. There are two falling edges coming under this width of the gate pulse, right? So it will be equal to 2 tick clock. So how much error will be there? We have actual 4, we are getting 2, so 50% error, right? Which
Right,
is
sir.
very high, which is not desirable. So in that scenario, reciprocal counter is, or reciprocal counting mode is undesirable. And that is why it may be fast, but it may not be precise in certain scenarios. And in such scenario, if you'll see, direct counting mode is more efficient, because maximum direct counting mode error will give you by 1 tick clock. Okay, so maximum error could be given by direct counting mode is tick clock. Sometimes that also could be avoided, right? And the maximum error could be given by uh, this reciprocal counting mode is how much? Reciprocal counting mode is how much? In terms of tick clock, you have to let me know. So we could, observe all the extreme cases, right? So let us suppose in any cases, if it is a starting, if this gate pulse is given just before the falling edges, let's see, it is just given before the falling edges. So this is the new gate pulse, and it is just ending before the falling edges, or it is just ending after the falling edge. So in such scenario, in red curve, which I have drawn, for this red gate pulse, this counter will be, providing how much measurement? How much measurement in terms of tick clock? This red one, total time is, will be, because this red pulse will see four falling edges, right? This is also a falling edge.
Right, sir.
But since it will not go till that point, so now in this scenario, it will read up to, 4 tick clock. And time is, and the extreme. So this is the best scenario, that it is just starting before the falling edge or clock pulse, and it is ending just after the falling edge clock pulse. So this is the best scenario. So here the error will be almost zero. It will be almost zero. Why? Because still there are some scope of error. Okay, but that is very minimum. So this is the best performance. And the worst performance we just saw, that it could end just before the falling edges, and it will begin just after the falling edges. So the maximum error could be 50%. So whatever the case we solved on first time, that will be the maximum error it could produce. Okay, nothing more than that. Not more than 50% ever this measurement way will provide you. Okay, you got why the maximum error could be 50%, or shall I repeat it?
सर एक बार रिपीट कर देने से अच्छा है।
ओके ओके ओके, कर देता हूँ। सो अगर ये गेट पल्स इन ब्लैक वन, राइट, ये गेट पल्स ये फॉलिंग एज के जस्ट बाद से स्टार्ट हुआ और ये फॉलिंग एज के जस्ट पहले खत्म हुआ, then it will see only two falling edges, right? And however, the total time of the gate pulse is equal to, very equal to 4 T clock, right? Because this is the, okay, so let me also identify this is the T clock. Otherwise, you might be thinking कि हवा में T clock. So this is the T clock, right? So this is one T clock. This is again another T clock. This is again another T clock. This is again another T. Oh, okay. Since we are dealing in terms of falling edges, this should be one T clock. This will be another. This will be another. This will be. So
Right, sir.
there are 4 T clocks, right? Now इसको fresh बनाते हैं. Now the first scenario, that it is getting started just after the first falling edge, okay, and it is getting ended just before the third T clock, okay, third falling edge, right? Not 30, third falling edge. Then in this scenario, this gate will register the value of 2 T clock, okay. But however, this time period is very close. This is the measurement value. But what is the value of actual? It is very close to, 4 T clock, right? Because if had it been, you might be thinking that it should be 3 T clock. I know, because it seems like that. So had it been, just started from here, what would have been the frequency or time, total time? 3 T clock. Okay. It is very close to 3 T clock. Okay. Since we are measuring in terms of, width, but if you just see the falling edges, right? So what we are considering the best case scenario and the worst case scenario. Okay. So the best case scenario is this one, the blue one. So blue one का क्या
Right,
है
sir.
कि जैसे ही पहला falling edge के just before it will start and the last falling edge के just after it will end. Okay, so that will be the best case scenario. And in that scenario, it will measure it will see 4 falling edges, right? And however, this 4 falling edges is the best case scenario. But is it, if even this is the best case scenario, but is it true? How much is the total value of the time this time? This is close to 3 times of T clock, right? 4 falling edges we are registering, but actually it is just higher, slightly higher than 3 T clock. If you measure, this whole T clock is 3 T clock, right? Fourth is coming because fourth is just a starting. before the finish of the gate pulse. So 4 falling edges, it is registering, but the time period is 3 clock. So this is the best case scenario, but again, in this scenario also the error is there. Error in terms of it is registering the advanced T clock, right? So in such scenario, if you solve the problem, you will have to, write the error in terms of percentage. So error will be a 4 T clock and the actual is 3 T clock, right? Divided by 4 T clock. So it will be 25%.
Right.
So in best case scenario, also the error is 25%. Okay. And in worst case scenario, क्या होगा? The red one. Sangeeta, you got the idea during the best case scenario why the error is coming as this 25%? Okay, great. Now, during the worst case scenario, what will happen that it is just starting after the first falling edge and it is just ending before the third falling edge. Sorry, fourth falling edge. So total falling edges it will register will be 2 falling edges. This much this gate pulse will blue one will register. Okay. Now, however, the total width of this blue pulse is, how much? It is very close to the same. Again, it is very same as previous case, so it will be equal to 3 clock. So since earlier we counted it from here, that is why we got 40 clock, and that is why earlier we calculated that 50%. But however, it will be like this, and this time the error will be two. It will register 2 falling edges, means 2 T clock. Do not get confused with that, okay? And the actual is equal to 3 T clock. Okay, so the error will be again, error will be 3 T clock. Let me write it that side. 3 T clock minus 2 T clock divided by 3 T clock. So it will be 1 by 3 T clock. So 33%. So that much will be the maximum error. Okay. So I hope you got this idea. So this error value will lie between, it should be higher than, it will be higher than, this value. No, it could lie between any value, but generally, whatever you will solve, that 25% and 33% will be the common, but we will solve it with the examples. So this is what happens with the reciprocal counter. That's what I was trying to interpret. Okay. So this much would be the maximum. Beyond this, it should not possess any error value. So if you take positive edge or positive triggered, in that scenario you could think in terms of, or you could solve on your own with pen and paper with all these clock diagrams, and you may be able to get different value, but that depends from edges to edges. Okay. So again, any final doubt in this, or shall I explain once more? थोड़ा confusing था. This error value should not be 50%. This was wrong. Why? Because I was calculating from this end. But if your clock is negative edge triggered, then you should start with the falling edge. And if your clock is positive edge triggered, then you should start with this point. Okay. Okay. Any final doubt on this? Okay. Okay. So, nice. So let's solve one problem. Sangeeta, did you get this?
Yes, sir.
Okay, great. So now we are measuring a frequency, of 33 hertz. Okay, using a digital frequency meter with gate time is equal to how much? 500 millisecond. Okay, in the direct counting mode. Okay, we just discussed reciprocal counting mode, and this problem is based on direct counting mode. But we will also solve this problem using reciprocal counting mode. Okay, how much maximum error could be produced? Error can occur. Okay, that we have to solve. Okay, so in direct counting, okay, the maximum will be, higher than that value whatever is recorded, and minimum will be lower than that value. So let us see the minimum possible value of the counter and the maximum possible value of the counter. Okay, so first thing, since it is 33 hertz of the frequency, right? So how much is the period time period of this will be 1 by 33 hertz, which is nothing but 30 millisecond, 30.3 millisecond. Mhm. So I'll draw the both diagrams. So this could be asymmetric also with a different pulse width of the positive and zero, right? But we prefer to draw it as this fashion. Okay. So how many, clocks will be there, or how many clock pulses will be there in one gate time? Because it is a direct counting, that is why gate time is high, right? So in one gate time, how many clock or how many signal, how many times the signal will repeat itself? So it will be 500 by 30.3, which will be 16.5. Okay, so this many times this gate pulse will be given till this signal will complete its 16.5 times, right? But in our meter, in our frequency meter, we will get only integer terms. Okay, so either our output of this direct counting mode could be how much? 16 or 17, right? Not nothing higher than this. Our counter will either read 16 or 17. Okay, or if you see, if you ask, this is what, this is not in hertz, this is not in seconds, this is cycles, 16 or 17 cycles our unknown signal will complete. Okay, so it will be 16 time period, 16 time times of this frequency signal, unknown signal. Okay, right? Now, or in other words, you could write as counter output. So counter is what? How many times any unknown signal completes its what to say cycle. Okay, so that is the value of counter it will register. For one complete cycle, it will register as 1. So it is completing either 16 or 17. Okay. So if you see the minimum frequency error, the minimum frequency error and the maximum frequency error, in terms of frequency, now I am talking. Here till here, it was in terms of counter and time period. Okay. Now, the minimum possible value of counter is 16 or 17. Now, corresponding to that, minimum possible value of meter reading, because our meter will read in terms of what? It will not give you this many cycles our signal has completed. It will give you only frequency. So now you have to bring it in terms of frequency. Okay, so we understood by the statement of the problem. Is there any issue till this point? Any doubt till this point that the minimum counter value will be 16 or 17? Is there any doubt regarding this? Based on these calculations, I can repeat. It is very critical to understand this. Shall I repeat it once?
Yes, sir. Repeat again.
Okay, thanks. So सिग्नल का फ्रीक्वेंसी है 33 हर्ट्ज. ओके, गेट टाइम है 500 मिलीसेकेंड. ओके, सिग्नल का फ्रीक्वेंसी 33 हर्ट्ज. इफ आई एम कन्वर्टिंग दिस इन टाइम पीरियड, इट इज 30.3 मिलीसेकेंड. ओके, so in one gate pulse, which is 500 millisecond, this is 500 millisecond, this clock exact time value will be equal to 16.5 into this t of unknown signal, which is 33.3 t of this unknown signal, which is nothing but 16.5 into this value, time period of unknown signal, that is 30.3. So if you multiply this, you will get the exact value, this 500 millisecond. So एक ग्रेड पल्स में 16.5 टाइम्स अपना फ्रीक्वेंसी, 16.5 टाइम्स अपना साइकिल कंप्लीट हो रहा है, राइट? एंड जितना टाइम्स वो साइकिल कंप्लीट हो रहा है, दैट वैल्यू विल बी शोन बाय विच कंपोनेंट, दैट इज काउंटर. वो काउंटर दिखाएगा कि 16.5, बस काउंटर कैन नॉट शो इन फ्रैक्शन, it has to show in integer, so it will show you either 16 or 17. Okay, so counter, इसलिए मैं बोल रहा हूँ यहाँ पे counter output should be either 16 or 17, right? Clear
Okay,
है
sir.
यहाँ तक? Okay, now
Right, sir.
but our meter will not show the value of counter, it will show the value of frequency, right? So now I have to deal in terms of frequency. Till counter it is very convenient for us, but in terms of frequency, what will happen that, yeah, so the minimum possible counter value, first I'll write, counter reading will be 16. So minimum possible frequency will be how much? Frequency read by meter will be how much? How much? 16 by 16 into frequency of gate or unknown signal. Gate pulse or unknown signal?
Unknown, sir.
No, 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 no. Minimum possible value of the meter reading will be, minimum possible frequency read by the meter will be 16 into 16 into frequency of gate pulse. Or you could see not frequency because gate could repeat, but we have only one pulse of gate, which time is 500 millisecond. So we have to write 16 by 500 millisecond. Because 500 milliseconds में 16 cycles complete कर रहा है, right?
Yeah. Yes, sir.
Yeah. So time has to come on denominator. Okay.
Yes, sir. Yes, sir.
अभी क्लियर है, राइट संगीता?
Yes.
ओके निरंजन?
Yes,
ओके
sir.
ओके
Yes,
ग्रेट,
sir.
नाइस। सो अभी यहाँ पे फ्रीक्वेंसी हम लोग फाइंड आउट कर देंगे, मिनिमम पॉसिबल फ्रीक्वेंसी रेट बाय दिस मीटर which will be 16 by 500 millisecond, and if you are removing millisecond in term with seconds, so you have to multiply 1000, so it is nothing but 32 hertz. So this is the minimum frequency, possible frequency rate by meter. Okay, क्यों? क्योंकि देखो 16 साइकिल्स कंप्लीट हो रहा है, बट एक साइकिल का तो फ्रीक्वेंसी इतना कम है, तभी तो this much frequency will be read by the meter. Okay, so that much will be the minimum. What about the maximum possible frequency? So maximum possible counter value will be,
17.
yes, excellent, 17. So maximum possible frequency read by meter will be how much? 17 divided by time of the gate pulse. Exactly. So 15 milliseconds. So again, you have to convert in second, multiply with 1000. It will be 34 hertz. Okay, right? Now, oh, okay. So now we have two value, maximum possible frequency and minimum possible frequency, right? So what we could do, we could take as a, so there is difference. What is the actual frequency of the unknown signal? Because we calculated maximum possible frequency shown by the meter, we calculated minimum frequency shown by the meter, and actual frequency was given in the problem, right? Actual frequency was 33 hertz. So we are getting from the counter either 32 hertz or 34 hertz. So there is error of 1 hertz, right? We have error of 1 hertz because either it will show 32, then only the error will be by 1 hertz in negative direction. It is undermining the actual frequency. Or if it is showing 34 hertz, it means it is over predicting or overestimating the frequency value. So the error is 1 hertz, right? Is there any doubt in this? But we have to calculate in terms of percentage. Any doubt? So
No, sir.
percentage, okay, great. So percentage will be 1 by how much?
33.
33, excellent. So it will be into 100%. So it will be 3.03%. So this much of error only you are getting with direct counting mode. Okay. Any doubt with this problem?
No, sir.
Great. Okay. In current week's assignment, have you been given with any questions based on indirect, sorry, reciprocal counting mode? Calculation of either based on a reciprocal counting mode?
No, sir.
No, you are saying no?
Yes, no, sir. Reciprocal counting based कोई न्यूमेरिकल्स नहीं है, बस एक थियोरेटिकल क्वेश्चन है कि
Okay,
आप किसमें मेजर करना चाहेंगे, डायरेक्ट और रेसिप्रोकल.
okay, okay. तो that I think हम लोग डिस्कस कर चुके हैं ये पार्ट, राइट? और also some condition दिया होगा ना कि when we want fast response or slow response or precise response, right? Okay, so I also could not see any questions, any problems based on reciprocal counting mode. So first, I have to frame a question for that. So I don't think as of now. Let me see from the lectures. Hmm. Okay, yeah, we could see. Hmm. Let us see some part based, some problems based on errors. I think that was mentioned in lecture as well, but no problem. Okay, so just like that, just before this problem which I explained, we are going to solve in terms of error percentage error. Okay, so we have a signal, okay, input signal with with clock of negative edge triggered. So this is the symbol of negative edge triggered, right? Okay, so let us suppose we have this kind of, again with convenience we are considering with 50% of duty cycle. Okay. 1 2 3 4. Now our gate pulse will start from here, from the middle of the first, and it is ending at the middle of the last. Okay, so let me draw the gate pulse. So this is my gate, this is my input signal. Okay, and again this is since negative edge triggered, this is 1 T clock. Okay, hence you could observe as others. Now here, how much we are going to see, how many cycles are actually being completed by the input signal, and how much cycles or how much time are we observing. Okay, so first thing first, we could easily see that in this time in this time there are three falling edges. Okay, so falling edges are three because negative is triggered. Okay, so how counter will show the value 3 cycles, so 3 T clock. Okay, this will be the value of counter. Now, how much is the gate time? How much is the gate time? So again, in the last problem, after the calculating the value of counter, we came back in the frequency domain. So again, here also we will come back in the frequency domain. So it will be equal to f clock. Okay, this will be the counter, this will be the output frequency which we will see. Okay, but how much is the time of this actual gate pulse? Because since I have provided from the middle to middle, so how many cycles are being completed? So for that, one, one, one. So, so the actual gate time is also how much? 3T clock. Okay. So now, if you will, divide the gate pulse time by the frequency of the frequency of the input signal. So frequency of the input signal is, if we are going to calculate frequency of the input signal, is how much? 1 by T clock. And the gate gate time is 3 tick clock, right? Sorry, gate time is 3 tick clock. So here the output of the frequency, or you will see, estimated frequency will be 3, and actual is also 3. So your error will be, you know, if you see if input is equal to if clock. So you have to calculate gate time. Gate time is 3 tick clock, and the total time is taken as also get 3 tick clock. So the overall in last problem, what we did, that the maximum possible counter value, this value, we divided with what? Maximum possible frequency reading by meter. Okay. So that we calculated with how much was the gate time. So maximum possible counter value we got here, how much? Maximum possible counter value we got 3, 3 tick clock, and gate maximum possible value, sorry, I think I'm confusing. So maximum possible frequency read by meter is the gate time, which is maximum possible value of output frequency is equal to this counter time, which is 3 by t clock, 3 by FCLK, divided by total width of the gate, right? In last question also we did like that. The total width of the gate is nothing but 3 t clock, which is again 3 by f clock. So which will be equal to, sorry, which will be 3. So it will be equal to f clock, because this will be the width of the value of the, this will be the value of the counter. So you are going to get error is equal to 0. Okay. And from observation also you could see that 3 falling edges we are registering at the output of the counter. Okay, so we are observing 3 t clock at output, and the actual gate width is also is equal to 3 t clock, right? This is 3 t clock, and this is 3 falling edges. So the error is going to be 0. Okay, if you are confused about this, let me show you one more scenario similarly, in which you could see the error. Okay, so in that scenario, it will start from the inverted thing, I guess. Yeah, and our this gate pulse will start from this point. Okay, it will start from this point, and it will end just before. How much portion is here? That much portion will be here. Okay, so, and again at falling edges we are going to have counters. So this is our gate pulse width. Okay, so here at falling edges our counter will register. Okay, so how many falling edges our counter will see during this gate pulse? So 2 falling edges.
2.
Exactly. And how much is the actual width? So this will be here. This will be completing, I guess, just after it. Yeah. So this is 1. Mm, this is 2. Okay. This is 2. And this much is covered. So this is half. What I am trying to make out, because since I am creating this part, so this should be like this. Since it is falling, let me extend it a bit till the rising part. Okay. Okay. Just before the rising part. So this much width I am going to have here, so that I'll have total 2.5. Okay. Now from here to here 1, from here to here 2, T clock, and from here to here half T clock. Now I am introducing intentionally error so that we could calculate the percentage error, and that is how questions should be asked based on reciprocal counting. So this is T clock, this is T clock. Here this is the gate. Gate width is nothing but 2.5 T clock. Okay, this is like reciprocal counting will work. So our counter value will be how much? 2. Okay, and actual actual time period is actual time is 2.5 T clock. Counter is showing 2 T clock. Our actual is 2.5 T clock. So if I am converting them in frequency measured of actual signal, sorry, of input signal, how much will be the frequency measured of input signal? 2 by f clock, right? And how much will be the frequency of the actual frequency measured and actual frequency? Let me write actual frequency. So the actual gate time is how much? 2.5 T clock. Okay, so which is nothing but 2.5 by f clock. Okay, till here, is it fine? Any doubt? Shall I repeat it once?
Fine, sir.
Fine. Sangeeta?
Yes, sir.
Fine.
Okay, sir. Fine.
Or any doubt? See, whatever I have created gate pulse width in such a fashion that the actual width of gate is 2.5 T clock, and the registered by the counter is 2 T clock. Okay, so that is what I have written. And now, since our meter will show the value of frequency, so I am converting them in terms of frequency. So the frequency measured of input signal will be 2 by f C clock, and the actual gate time is 2.5 T clock. So in terms of frequency, we should not say frequency, but it is inverse of time. So which is 2.5 divided by f C clock. So now error, if we are going to calculate, error will be 2.5 by f clock. No, error will be how much? 2 by f clock. This one is shown, and the actual gate time, which is 2.5 by f clock. Okay, so the error will be 2 by 2.5 to 100%. So, so the error is I think 80%. 80% is 2 by 2.5. It is showing 50% out of 2. So, so 1 minus 8. 2.5 by t clock minus 2 by t clock divided by 2 by t clock. So it should be 2.5 minus 2 divided by 2 or 2.5, 2.5. Because whatever is the actual, that we have to take on denominator. So 0.5
Yes, sir.
divided
Right,
by
sir.
0.5 divided, thanks. So it's 1 by 5 into 100%. So it will be 20%, right? Yeah. So error is 20%. Okay.
Okay.
So I hope you will be able to solve the error-based problem. Okay. You have to carefully observe that how many actual cycles are there and how many edges the counter is registering, and the difference between them is the error. Okay. So this is all from my side for this week. Any final doubt you could ask? And I hope you will be able to solve this week's assignment. Any final doubt before winding up the session?
No, sir.
No, Sangeeta?
No, sir.
Okay, great. Thanks a lot for joining, Niranjan, Sangeeta. Thanks a lot. I hope you will be able to solve the assignment 7. Thank you. See you next week. Bye.
Bye.
Thank you, sir.
Bye. Thank
Good
you.
night,
Good
sir.
night. Good night. Good night, Niranjan. Good night, Sangeeta. Bye.